Thank you very much for the kind introduction, Rob, and thank you for running all the different C++ events that you do. I'm going to go right into the presentation, which is one C++26 app, three ways: by hand, by AI, and together. So we had an inflection point a few months ago. Here's a tweet recently from Andrej Karpathy, who is a co-founder of OpenAI, coined the term vibe coding, um, very reputable. And he says, I rapidly went from about 80% manual plus autocomplete coding and 20% agents in November to 80% agent coding and 20% edits and touch-ups in December. This is easily the biggest change to my coding workflow in 2 decades of programming, and it happened over the course of a few weeks. So what does this mean to us? And our agenda is we're going to build the same application in a variety of ways of using or not using AI, compare the results, and learn from it how to get the most from today's tools. Um, so the question is, what app should we choose? Well, here's what ChatGPT says LLMs are best at. Say, AI coding tools tend to work best when the application is clear structure, strong libraries, and limited system complexities. And the canonical sweet spot is a CRUD database-backed web app. CRUD stands for create, update, and delete. And examples are dashboards, admin tools, internal business tools, SaaS products, and the like. And they work well because there are hundreds of thousands of examples on them on the web. The patterns are well understood now with routes, models, and forms. And there are a lot of robust frameworks that can be effectively used. But what about apps that don't have well understood patterns? They don't have lots of existing examples, and they aren't based on frameworks. Well, let's do a specialized C++26 app and take this out for a spin and see what it can really do. Because, all right, C++26 patterns are not well understood yet. There are not many examples, and our application is not going to be based on a framework. For our sample program, I've written a sample program that does XML data binding for C++26 using a variety of advanced C++ features. And I'm going to begin by describing the program. An XML schema specifies what an XML document can look like by defining a type library. So here we have an XML schema for a type named note. It's a complex type, which means it can have stuff inside it that are going to be a sequence of to, from, heading, and body. So what would an XML document that satisfies this schema look like? Well, it'll be a document that has a note tag, and within it, it has a from, to, heading, and body tag. And these schemas can get quite sophisticated, but we're going to start with this simple one. The goal of our program is to read an XML schema and then generate a C++ class or a struct or something else that matches the type in those XML schema, as well as code to serialize and deserialize the objects to XML. And this makes working with XML data easy and natural in C++. Before we go into the program, I want to talk a little bit about the design philosophy I'm going to apply to this and to most of the programs I write. And um, I like to design my application first with design patterns. And these were originated by the Gang of Four's design pattern book. Um, Number of years back, it won the ACM SIGPlan Programming Language Book of the Decade Award, and it's one of only three software engineering books on Wikipedia's list of important publications in computer science. The other two are the Mythical Man Month and the Cathedral and the Bazaar. So this is the only one that actually deals with code. And Wikipedia defines a design pattern to be um, a general reusable solution to commonly occurring problem and not a finished design that can be transformed directly into source code. In other words, design patterns are a language for humans to use to figure out what's the right way to design an application unencumbered by the details of actual programming. And I would say, are we sure? What if we could just write a design and generate a program directly from that? And Andrei Alexandrescu wrote a very influential book on just that theme called Modern C++ Design. And in fact, one of the Gang of Four authors added to the forward, wrote the forward of the book and said that templates allow you to create an embedded domain-specific language for implementing design patterns. And in fact, much of the development of C++ in the um, over a decade since this book came out, over 2 decades, I believe have been driven by the ability to produce more and more of your design patterns. Just state what your design is, and then the templates produce the code. So our program is going to use modern C++ to leverage three popular design patterns, which are factories, visitors, and parallel hierarchies. And our code is going to be powered by modern C++, which really is much better than earlier versions of C++. So we're going to use a lot of great features. So from C++ 17, we're going to use deduce non-type template parameters, fold expressions, inline variables, variant optional visitor string view, C++ 20. We're going to use concepts and formatting ranges in std format, and we're going to add formatting ranges from C++ 23, inheriting from std variant, and C++ 26 is a huge lift for us because it introduces both static reflection and optional references. So there will not be a single pointer in our entire program. Let's talk a little about these design patterns and how they're implemented. We'll begin with factories. And the abstract factory and concrete factory are probably the most common design patterns in programs. So most large-scale programs will have something like the following in them. Here we have a class widget factory that's a pure abstract class with only pure virtual functions. And our widget factory can create a window, it can create a button, or it can create a scroll bar. And then they return a owning pointer to that. Well, that's the abstract interface for working with widgets. there's also a concrete factory that will produce actual widgets. And this has a lot of benefits to it. For example, not only can you write the same program and have it work for many different UI environments, but you won't have to inadvertently worry about creating incompatible objects, like trying to put a Windows scroll bar on an Android window. So here we can have a Microsoft Windows widget factory that inherits from widget factory, and it overrides the create window method. And likewise, Android widget factory is also going to override all the methods. And as long as I'm using my abstract factory, it's only going to give me Windows widgets, or it's only going to give me Android widgets. So putting together, my code will look something like this. I'll get an abstract widget factory on top, and the rest of my program only uses generic widget functionality. So if we switch to an Android widget factory or a material widget factory or something later, it will still work because my code will just say widgets create button. So what's the problem with the factory pattern, right? Well, they're great to use, but they're hard to write. There are actually dozens and dozens of different kinds of widgets, and manually implementing all of the different factories is going to be tedious, um, error-prone, and brittle. And this is important because the friction that of creating a factory is enough that programmers don't use factories many times when they would be better off doing it. And there's a lot of copy pasta errors when they do this. So it's natural to ask, can we use a template to generate for us? And we're going to use a number of techniques that are great to know about, and hat tip to Andre Alexandrescu for all of these and the patterns, so you can see that in his book. So these are going to be templates, typeless, template virtuals, parallel hierarchies, and reflection. So typeless are a very simple idea that says sometimes we just want a list of types, not because we're going to create objects from those types, but simply to power variadic templates. So, for example, we could feed the list of types made by a factory into factory template, which will then create a factory for those types. And the definition of a type list is as simple as can be. Once we have templates, we can manipulate them at compile time with meta functions. So, for example, here's a meta function that we can use to replace a type in a type list with a different type. And you can see it recursively walks through the type list looking at the head until it sees the type that it wants to replace. And here we can see that if we have a type list of int char, this says vector, but I guess that should be like vector int because vector is a class template. It's not a type. Um, but it will replace that with another one. Now, our factory pattern relies very heavily on virtual methods, but since we're in the world of templates and we got to templatize on what the types are, we run into the problem that method templates cannot be virtual because what would the vtable look like? So if we want to implement the factory design pattern, we're going to need a solution. And let's see if we can come up with a way to simulate virtual method templates. Well, we can't they're not methods, so they can't have v-table entries, but we can call ordinary methods from our method templates, which means we're going to want to create specializations to call the methods that we want. Okay, so what interface do we want to support here um, to make method templates virtual? Well, suppose we want fint, fdouble, and fa to be virtuals that can be overridden in a derived class. Well, what we could do is have our method template call helper methods that rely on overloading by passing in an argument of that type to choose the right helper. And then the derived classes from S could override those different helpers because they're actual virtual methods. The problem is F helper, when I call F helper with an A, I have to construct an A. An A may lack a default constructor, it may be heavy to construct, and constructing it may have side effects. So this approach doesn't quite work. What we need to do is have some kind of lightweight type that's not abstract, it's not default constructible, and it's cheap to construct that tells us what type we're interested in. So I'm going to construct another super simple template, which is just a tag type template that is a single template argument and is an empty class. Well, now our method template can invoke the F helper with the tag type that can be produced almost for free. And now we have virtual methods that can be overridden. Now, the only problem with this is it's tedious and error prone to manually define all of the helper virtual members. Well, that sounds like a job for variadics. Let's begin by defining a class template that holds just one helper and then use variadics to inherit from all of them. So what we'll do is it's better to put these in base classes, which will make it easier to inherit from. We don't have time for all the technical details, but you can work them through or ask ChatGPT about them. And now we're going to inherit from all of these holders, and that will give us the virtual methods that we want. So now we can create a class with a method template that actually is virtuals for all the types we're interested in. And this is something that we can use to automate with factory templates. So we can have abstract factory and concrete factory templates that give the things we're interested in the factory producing and how to override them. Okay, so we have an abstract creator that we inherit from, and that gives us our abstract factory, and it has a single create method template that calls the appropriate abstract creator, which is the virtual method that can be overridden, and then the concrete factory overrides the method in the abstract factory, and we're done. So one of the things we'd like to do here is improve our factories with C++26 reflection, because maintaining the list of all widgets will be painful to do manually. And Barry Revson recently gave a global CPP talk to come up to speed in just an hour on reflection, right? And this will allow us to say is our widget factory can just produce anything that inherits from widget. Now, unfortunately, reflection doesn't give us all the types that derive from a given type, but we can work around because it lets us enumerate all of the symbols in the namespace to get the result that we want. So I can actually create a derives of class template. We're also interested in the visitor pattern. There are many versions of the visitor patterns. And the idea is it's common to wish that a hierarchy of classes that you're using have some extra virtuals, but you might not be able to add them. Maybe they're not your classes. Maybe they're only relevant to your program and you don't want to clutter things up. So in my day job, we write entertainment experiences. And I might wish the third-party animal hierarchy had a hit points virtual method, but that's specific to my game. What if there's a way for clients to inject virtuals into an external class hierarchy? And to do that, you can stick a virtual accept method in each class that you pass a visitor class, which knows how to visit all the types in the hierarchy. And this shows that a gorilla can have a lot of hit points where a general animal only has two. So I advise most of my students to make most of their hierarchies acceptable so they can be customized by their users. But putting the accept method is cumbersome and error-prone copy pasta. Now, I get sad every time I realize that C++23 deducing this doesn't solve the problem because you can't deduce this for virtuals. So instead, we're going to make principal use of metaprogramming um, to create an acceptable template wrapper that does this. And this will mean that we don't have to inject it everywhere. Finally, I want to use a parallel hierarchy family design pattern where the idea is in my interface, I have a bunch of abstract classes like diesel locomotive inherits from locomotive, and the concrete types that implement them should also have the same inheritance relationship. So my model diesel locomotive should not only implement the diesel locomotive interface, but it should also inherit from model locomotive because a model diesel locomotive is a model locomotive. Now, unfortunately, there is no basis of type trait, and I've been trying off and on since 2009. However, with reflection, we no longer need to wait, because we can write our own base class type trait. And here's how you do it. And if this notation is unfamiliar to you, like it was to me a week ago, I very much encourage you to look at Barry Revson's Global CPP talk, which is really excellent. So now the other thing we want to do is make sure we represent our concrete factories as a template. Because if we just hit a class named model locomotive instead of model angle brackets locomotive, there would be nothing we could hang our hat on for it to recognize that it's actually implementing locomotive for the model family. Making that a template solves this problem for us. And now we can do all of our implementations. So there's a lot more to our sample program by hand. It took me over a week of work to write, spread over time, but we now have all the tools we need for a principled implementation that's robust, extensible, and maintainable. And please, I'm going to tell you a secret, which I didn't write it entirely by hand. I used AI for autocomplete and for C++ error messages, but I didn't give it any tasks to write code. And even for autocomplete and error messages, uh, for a program like this, it was very hit or miss with both of those. Nevertheless, you could say the same thing about me, right? I often had trouble making sense of the error messages myself. So, how did our program work? Well, it uses the libstud XML library to read in the schema and then invoke a factory that constructs a hierarchy of types. Now, this gives us a faithful internal representation of the XML schema, but there are many things we might want to do from this hierarchy. We might want to generate declarations, we might want to generate definitions, we might want to generate structs or classes, convert to JSON schema, etc. So we don't know what methods to put in. Well, this sounds like a job for accept. And in fact, our type hierarchy is a complete Rorschach test. The only method in it is the accept method. And we use our acceptable template to inject the accept method. And then we have an abstract formatter class template that says how to format each kind of XML schema type and concrete hierarchies for all the different types of things we'd like to generate. So um, I should also point out that I have an indent stream class that's handy for code generation that uses a custom stream buff to make sure each line is at the right level of indentation. And now any new feature is an extension point to our visitors. So generation is fully pluggable and extensible. And everything we want to do can be encapsulated in one place. And there's a principle here that's called prefer concentrated complexity to diffuse complexity, because you or an AI can only keep so much in their context. So let me just briefly show you the program. Okay. And let's not do this one. Ah, there it is. Okay. So we have a node example program that just reads our node in from XML. We previously ran our program to generate headers from this XML schema, and then we have a CMake test to test it. And if we look at what was generated, we can see it's what we expected to generate, right? The struct that we want and the ability to read and write it to and from XML, and it created a ton of boilerplate for us, which is terrific. And if we look at the code that itself, let's go and look at some of the code. We can see everything we want to generate a description for is nicely handled by a concrete factory. So if we have Boolean types or int types or the like. Now let's move on to vibe coding, right? So instead of worrying about all of that, let's just say what we need and have Claude Code do it for us. Well, um, what I did is I just gave it our note test case and the above prompt. Write a modern C++26 XML data binding program that includes enough of XML schema to run the sample test correctly. Use libstd.xml, which is available in Conan for XML parsing. Make sure you follow modern C++ coding and design practices, and don't cheat by looking at anything outside. The first few times I tried it, it looked for my implementation on the computer and kept finding it. Um, and then, since I wanted to vibe code, I run Claude with all permission gates turned off. And then it created it an hour versus days of writing it by hand. Well, that's not bad. And if we look at what it produced, it's not um, it's not that bad of code, right? It's a lot of by hand parsers for each different kinds of things. And if we look at how it generates, well, you can see it's not raising the abstraction level that much. It's manually putting in all of the amount of indentation that's necessary for each of these things. So now if you had nested types, you need to rewrite a lot and the like, but nevertheless, it's very clear sort of tactical code, like, you teach in an introductory C++ course. And it saved a lot of time. It worked and it wasn't terrible, right? Now, then I asked it to add various features, right? So, pluggable generation, where it could generate classes with getters and setters instead of structs, more coverage of XML schema, generate a JSON schema from an XML schema, etc. And that was also done in under an hour. Doing that manually would have taken me a week, right? Oh my God, right? Now, is there a catch? Well, yeah, because it lacks abstraction, um, the complexity is diffuse rather than concentrated. And we can see every new feature actually, if we look at the diff, they end up having to rewrite uh, a lot of the um, program. So here, where we just added support for a few XML schema features, you can see it had to like basically rewrite the generator everywhere because it didn't do things like using visit as an extension point or the like. So um, I should note that CRUD web apps work better because the AI has architectural patterns to follow. But when we're doing a new type of things, uh, they tend to create diffuse complexity rather than invent pattern. Well, due to this, it'd be very difficult for a human to maintain and review this program. And worse yet, Karpathy, also Boris Cherny, who invented Claude Code, say production code must be human reviewed due to subtle mistakes, right? And go and look on X for recent popular post about Claude Code wiping out production database with the Terraform command. Now, one day this may not matter when AI becomes a reliable English to C++ or whatever compiler, right? No one cares if the machine code generated by a compiler follows the solid principle. But that day is not today. So the next question is there a Goldilocks solution? And that would be building together. So, how do we work together? Well, first, we create a minimal version using the full architecture, just enough to do the node example. Second, give it a context document like Claude.md with design principles, including to model off the existing code. Use the plan mode for each feature, then use a proper workflow where you review each feature after Claude implements it. And then you regularly run the Claude Code Simplify skill as well. So I did this, and this worked great. In a couple of hours, we implemented a boatload of features with high quality, with full test suites that um, would I've gotten around to writing them myself? Well, I like to think I would, but I'd like to think I would, right? And this included complex um, enhancements like adding extension types in XML schema or having a generator that doesn't generate C++, but it translates an XML schema to JSON schema. Either of these individual features would have taken me more than a couple of hours to implement by hand, and we implemented a dozen of those features in a couple of hours. Now, I did find important problems, both strategic and tactical, both during the planning stage and the review stage. But you know what? That's like being a team lead with a team of programmers that you're directing on your team. And it didn't really do worse than what I would expect for that. So and I should point out that even better, while this did take a few hours, um, almost all of this was Claude, and only maybe 20% of it was me reviewing. So this will not take much of my time at all. Let's go take a quick look here. So here, if we look at the change to add XML schema enumerations to the language, to our application, you can see because it's building off an extensible architecture, we know we can write robust programs and review them. So it added a new enum type. Uh, it added a new formatter for writing it to struct. It also added a new formatter to writing it to class that is getter and setters. Um, it created a test using an XML schema with the nums, validated, and it was done. So this is very easy to review and have confidence in, right? Even the more complicated ones, like adding type extension support, are very straightforward and understandable. Now, since most of the time is just Claude working in the background, using the Claude terminal or the VS Code extension really isn't the right way to go, right? Um, Instead, you want to create an engineering team in a software process that has agents in them. So there are tools like Ralph Blaster that you can use that create a Kanban board that Claude Code has. So now a task gets assigned to you when there's something for you to do, which means I don't need to sit around looking at the terminal or anything else. It just fits in my normal Kanban board. So let's fire this up and try to do one there. So I'm going to go to the directory um, that I have um, that I'm working in. I'm going to fire up Ralph Blaster. I already added this as a project. Okay, so now this is looking for jobs for Claude Code to do from the Kanban board. So here, um, I'm going to create a new ticket and going to do it for this project. So my request is add support um, for the XML : choice um, X, XSD schema element. XSD : choice, XML schema element, and that's enough. So I'm going to have it create a concise PRD for it, and um, let's have it save and generate the plan. Oh, add a ticket title, um, support XSD : choice. Okay, so now it's queued to plan. In a moment, we're going to see that this is going to find the plan. How come it's not seeing the plan? Because it's a demo, of course. Uh, let's just refresh this. There, now realizes the agent is online. Now it'll probably find the plan, and that'll get picked up. In the meantime, while we're doing this, um, can look at all projects, and we can see another one that I did there where it built a plan for fixing a bug that this had with optional XML schema elements. It did a root cause analysis, proposed a solution, tested it, gave a rollback plan, and the like. And everything, and then it went and did it. And I only reviewed these things when it told me there was something to review. All right. And um, I don't know why it's the agent isn't picking it up. Um, that's just a demo thing, but we see it works from them. And then it works through these. And now I can just have agents doing a bunch of features and I'm done. And at the end in the review, I get a pull request and I can take that. So, um, there you go. So What's the summary here from building one app three ways? Well, AI is the biggest advance I've seen in my 58 years of programming, right? And you aren't competitive as a developer without AI. But at the same time, AI is not competitive without you. So I hope this talk gave you some ideas from how to get the most from AI. And now I'd like to know if somebody has some questions.
I can definitely hop in here with some to start. One thing that I was watching as this was coming up or wondering about, as you're leaving the tools to do these revisions on this code base, what would we expect from uh, the stability of like APIs that you may be producing that others may or may not rely on. You may not understand exactly who all is leveraging your code base and in which ways throughout time. If you're just kind of leaving it to the AI to generate maybe more tactical code more often so it can reason about it and then rework it to its heart's content as it sees fit.
So that's a great question, Rob. And in fact, the Andrei Karpathy tweet that I mentioned goes on to say that it will, AI at the current level will often break unrelated functionality that there was even no reason um, to put in the change. And because of the diffuse complexity, it may break a lot as well. Um, so first, you do a lot of test-driven development, and it's great because AI is happy to generate large test suites. But the second is that's motivation for the workflow that I'm recommending in this talk, where you create a well-structured first version so that when it adds a new feature, instead of having it hack all over the code base, because you've architected it in a way where it has well-defined modular extension points, and you've told it to follow this style, the code reviews are actually relatively easy, and you're pretty confident that it's not going to break other things because unless it needs to visit an XSD enum, none of the code got changed, right? So I think the workflow I described in the model for programming is actually very much driven by um, by the exact question you were asking, which is a very, very legitimate concern.
All right, Visha.
Uh, yeah, I just was curious. I noticed you were talking about like Claude, but how do other AI tools compare, or is Claude supposedly uh, the best AI tool in this type of workflow?
Now, if I used, if I was using the newest Copilot or Cursor, I would give the same talk. And in fact, if you're writing code bases, um, in general, you create a engine independent document, right? And then just have your Claude.md and your .cursor rules.md and stuff like that all have a reference to that same document. So that way, if you're, um, if you're using Claude Code and someone else on your team is using Cursor and someone else is using Replit, so there's a .replit file and the like, you can all do that, right? Just like programming in C++ shouldn't mean that you impose your tools on anyone else who uses that. So I'll give a shout out to my University of Chicago colleague, Chelsea Troy, who wrote the online Claude Code course for O'Reilly, which is going to be released shortly. And she goes into great depth into things about how to, even though it's a Claude Code course, and how to make it so it will work with all of these tools. Because, 2 weeks from now, maybe, Copilot GPT-5.4 is going to be miles ahead of the other things. So you don't want to be too tied to a particular tool.
I then I think I kind of also had a follow-up question. Um, so it seems like you're talking about AI as generating code. However, what if you wanted to have AI interfaces that generate other AI interfaces, such that you basically want to have a tool that maybe for like a CAD CAM type of software where you're using AI or like AI to generate some sort of prompt or some sort of connection to another AI, to either observe or to generate like a CAD image or a CAD system, uh, based on like your how you do your regular workflows.
Yeah, so a lot of the same guidelines work for generating AI apps, but there are some nuances for like how to write AI apps. And my generative AI course at the university, we actually spend a lot of time on how do you program generative AI apps. Um, but from the 10,000 foot level, it doesn't, like most of what I said in this talk would transfer to that as well.
Jeffrey Howard.
Hello. I just had a question, sort of applying this coding framework from like a student or early engineer perspective. I haven't really dove into this stuff too much. I guess I'm curious, like, obviously when you were learning all this and becoming a better engineer, you didn't have access to these tools. Do you see this as being important to learning, how to be a strong engineer and getting there and already being really comfortable using all this stuff? Or do you think it's better to try and stay away until you really need it to build something quickly? Uh,
It's a du
yeah.
it's a double-edged sword, right? Because it's essential that you be an excellent programmer to review the subtle errors, right, that generative AI puts in the code. But Anthropic recently released a paper that showed that people who used AI coding tools as part of their learning did not learn to code as well as people who learned the traditional way. So you have a little bit of a catch-22, right? Um, I think the only answer is you have to be disciplined and honest about doing both, right? Like, do a lot of your studying the old-fashioned way. But also, if you're not great at using the AI tools, you won't be competitive either. So have a separate studying track of using AI to write, whatever kinds of programs you're interested in, whether it's C++ or something else. And, so you got to do what I did in this lecture, write the same program 3 ways. Um, because otherwise you won't have the skills to direct the AI.
Marcos?
Hi, I had a question. So there's this book called The Mythical Man Month by Fred Brooks, and he introduces a topic of a surgical team for software development where you have a coordinator, the surgeon, and a bunch of assistants who are each specialized in particular tasks for development. Do you believe the current state of the art and the example that you showed, the workflow, kind of ties well with that idea of, you have the developer driving the design and then individual tasks, containerized tasks for the agents?
Yeah, I didn't do it in this, you know, example to just, but that was a time constraint. And in fact, um, you know, I started to get into like these software engineering frameworks, like with Ralph Blaster and stuff like that. And those have teams of specialized agents. So one that's a code reviewer skill and one that's an UI expert. And in fact, if you do the /simplify command, which I briefly mentioned, um, it actually spins up three Claude specialized agents that are each specialized about looking for different kinds of complexity in your code. Um, by the way, on the /simplify command, just found a couple of minor bugs in the manual seed that I created um, too. So, um, it's not like Claude is philosophically opposed to, a kind of high level abstract design like that. It's just that it has difficulty creating it on its own without seeing it modeled. And, for CRUD web apps, it's seen it modeled. But for this one, I have to one shot prompt it with my own model, and then it follows it very well. But yeah, surgical team model is exactly what you really use in these production systems.
I have another follow-up question. We, as an industry, begin to adopt these tools more, from what, in my experience, when new tooling comes out, it tries its best to adapt to existing practices. But then over time, the industry adapts to what's best for the tools. Should we expect a transition in the sorts of design patterns that we look for in our code bases to better match what works better for these tools? And if so, is there a transition we should expect, or maybe a friction between senior developers that are used to older design patterns and the junior developers that are growing up without those design patterns but insisting on newer ones?
So I started programming um, um, 50, 58 years ago. And at one point, my most cited article was about when processors started doing branch prediction. And for people who aren't familiar with that in assembly programming, um, pretty much everything you did in assembly programming was about um, preventing branches from occurring, right? Because, basically it would have to go out to main memory again. So you would have thought that I would have felt good, right? Like now I don't need to worry about branches, right? And, you know, something that was spending 3/4 of my time was now going to spend almost none of my time. But what I actually didn't felt was I don't know how to program because like everything I knew about idioms and patterns was built around this. I had to start from scratch. Um, if you're vulnerable to the sunk cost fallacy, you're in the wrong career here, right? So yeah, you're gonna have to change those things sort of massively in unpredictable ways over time. And that's the nature of the field we're in, and part of why I love being in this field, right? It's always new.
With that, the one question I've also had in my mind around all this is if we're generating the code and generating the tests, and there are now developers I'm talking to that are generating their reviews with AI, what do you see is the point of having the code as an artifact in the middle there? And are we likely to move towards tooling where it's just generating the binaries directly and we act as basically QA to make sure that the final artifact meets the requirements that we envisioned with it?
Well, they're currently not able to generate that well, right? Both Karpathy and Boris Cherny say clearly if there's code you care about in production, then you need a competent human to review the code. However, Boris goes on to say there's a really worthwhile 90-minute podcast that Boris Cherny recently did about Claude Code and the future for it. And, he's the person who invented it. Um, where he says that's true today, but in 1 to 2 years, it's not clear whether knowing to code will be a valuable skill or not, right? And he puts out the idea that there's going to be a bifurcation of engineers who are happy about that because now they'll be able to create more stuff, or engineers who are unhappy about that because they love to code. And um, basically, we're kind of going to move from coders to builders. And um, his so his opinion is we're not at what you propose today, Rob, but we're maybe a year or two away from it. And, then there'll be a choice. Do you love to code or do you love to build? And that'll say whether you're happy or unhappy with it. That being said, everybody's crystal ball is terrible. There's no consensus on what's going to happen with this. So there are other reputable people with different opinions on it. But I think the future you named is at least plausible in the not too distant future, and maybe even likely. So I'd like to thank all the people who dialed in, stayed on the call, and hope this proves useful to them.
Reminder to everybody else, if you wouldn't mind giving a bit of a recommendation for the group to friends, coworkers, and stuff like that, help us spread the word of these sessions, would be greatly appreciative. Otherwise, we will see you in 2 weeks. Hope to see you on C++ Online later this week, though. Thanks again, Mike. This has been fantastic, and hope to talk to you all again soon.